Hello friends, I am Guna Mathivanan, Current Affairs faculty at Officers IAS Academy. In this video, we will be discussing our 41st hit list topics, that is regarding black hole. What is this black hole, sir? For which first we have to understand about star. So what is a star? Star is nothing but a ball of gas. Constantly there will be nuclear fusion reaction which will be going inside the star. There will be a point where the thermonuclear fuel in that star will be getting exhausted. Till that it will be shining, okay, the brightness of the star is nothing but it's because of the nuclear fusion reactions. Once the fuel is gone, the star is going to explode. So once the fuel is thermonuclear fuel, once it is exhausted, the star will explode. If this star, if it is going to be a big star, okay, if it is going to be a big star, it will explode. Once after the explosion, there will be some remains, some denser particles will remain. The denser particle which remains after the explosion, we call it as neutron star. We call it as neutron star. Now, assume it is a very big star, massive star, superstar, okay. So, massive star. When that explodes, okay, when that explodes, the explosion will be inward. The explosion, there will be inward explosion. Friends, we all know explosion is going to be outward, but imagine there is an inward explosion. When such massive stars, when they die, they explode, the explosion will be inward. All the constituents of the matter, all the components, the constituents of the matter, they will be falling inward. There will be a point where the mass will become zero, and there will be a point where the mass becomes zero, right? And that means the volume becomes zero and density becomes infinite, okay? There will be a point where the volume becomes zero and the density that becomes infinite. Massive star, superstar, explosion, inward explosion, there will be a point, all the constituents of the matter that is going to fall inward, it is going to explode, and it will be reaching a point where the volume becomes zero, density becomes infinite, and that situation we call it as singularity. We call it as singularity, right? That is called a singularity, okay. So this situation we call it as black hole. This is the situation of a black hole. This characteristics, this region will be calling it as black hole. So density will be infinite. Even if light is going to enter this region, light cannot escape. Light cannot be escaped because of higher density. Even light will be absorbed. It will not be escaped. Right? That too much density will find in this black hole. If you take this neutron star, friends, this neutron stars, it keeps spinning. It keeps spinning. That spinning is called as pulsar. Spinning is called as pulsar. Okay. Even this black hole, okay, sometimes they will be accelerating at a very high speed. These neutron stars will be spinning at a very high speed. So in 1916, Einstein, in his theory of relativity, he spoke about black holes. He said when a massive celestial body, when it is accelerating at a very high speed, Einstein in his theory of relativity 1916, he says that the massive celestial bodies, when it is accelerating at a very high speed, that is going to create ripples. That is going to create ripples in space-time. This ripples is called as gravitational waves. It's called as gravitational waves. What is space-time? We all know space is a three-dimensional model. Space-time is a four-dimensional mathematical model. So in this four-dimensional, right, in this four-dimension, in the space-time, we will be observing some ripples. These ripples will be coming from this, that is called gravitational waves. These ripples will be created This ripples or okay, this is ripples. Okay, this ripples will be created from a heavy object which is accelerating at a very high speed, right? So Einstein was saying, when you study these ripples, if you are studying these ripples, when you study these ripples will be moving at a very high speed. They will be moving at the speed of light, it seems. When you study this gravitational wave, then you can study the origin of the gravitational wave. What is the origin? Black hole. When you study the gravitational wave, you can study the black hole itself or neutron star itself. By studying the gravitational waves, we can study the evolution of space itself. 100 years after, in 2016, these gravitational waves were recorded in LIGO observatory. LIGO, Laser Interferometer Gravitational Wave Observatory in America. Maybe in some other video I will explain about LIGO observatories. In India also, in Maharashtra, we are planning to bring a LIGO observatory. Okay, cabinet gave approval in 2020. Right. So for this, for recording gravitational wave in 2016, in 2017 Nobel Prize for Peace was given for this, Nobel Prize for Physics was given for this particular observation of gravitational waves. So Einstein, 1916 itself, he spoke about gravitational waves, black holes, etc. Alright. So this is about black hole and this is about gravitational waves. So too many articles are coming in Hindu based on black hole, gravitational wave, based on stars and neutron stars in general, LIGO observatories. So I thought of explaining some basics about black hole and gravitational wave. Right? I hope the video was useful. You can download this presentation by clicking the link given in the description box. You can find out the correct answer for the question and give in the comment section, and you can give your feedback in the comment section as well. Right friends, so here I have given the highlights of my current affairs course. You can go through if you are interested. I hope the video was useful. So tomorrow I will meet you with another interesting, exciting topic. Till then, bye, take care.